So it's clear that it's just but natural in humans to make errors, as the saying goes, man is to error. Man is to error, and there is nothing we can do about it. We could always be making some errors here and there. So let's see how we can find or we can calculate an error. So the accuracy of an individual value or of an average experimental value can be compared quantitatively with the correct or accepted value by calculating the percentage error. So error or percentage error is calculated. Percentage error is calculated by subtracting the accepted value by calculating the accepted value from the experimented value. The accepted value from the experimental value. From the experimental value. So we will be dividing the difference by the accepted value and then multiplying by 1000. Dividing the difference by the accepted value and then multiplying by 100. And then multiplying by 100. So this can be presented, it is presented here, percentage error. You take percentage error is experimental error, a value, minus accepted value. You want to divide it by its accepted value again, and you multiply by 100. That is how we work it out. So percentage error has a negative value if the accepted value is greater. Percentage, these are points to note here. Percentage error has a negative value so it will have a negative value if the accepted value is greater the experimental value is greater than the experimental value. So it has a positive value. It has a positive value. If the accepted value is less than the experimental value. If the accepted value is less than the experimental value. So you would either expect it to be positive or negative. So percentage error has a negative value if the accepted value is greater than the experimental value. 2, it has a positive value if the accepted value is less than the experimental value. So let's look at one example here, then we see how it goes. So the question here, that is sample problem C, a student measures the mass and volume of a substance and calculates its density as 1.4 grams per milliliter. The correct or the accepted value of the density is 1.3 gram per milliliter. What is the percentage error of the student's measurement? What is the percentage error of the student measurements? So to solve this, you will go direct into solving. So solve percentage error is equal to value experimental, that is experimental value, subtract accepted value, so you will subtract accepted value, then you divide by accepted value again. Accepted value, then you will multiply by 100. Multiply by 100. So percentage error here will be, what we are given is the density is given to us for the first time, and that is in the first instance is the calculated one. Then in the second instance is the accepted value. So we have 40. Sorry for that. 1.40 gram per milliliter minus 1.30 gram per milliliter divided by 1.30 gram per milliliter multiplied by 100, then what we will get should be the percentage value here. Why? Because you will see here that the milligram and the milligram will cancel. So we have this, multiply this, divide by this, multiply by 100. Oh, it is minus here, so let's first do it with the calc here. So we have 1.40 subtract 1.30 multiply by 100, then divide by 1.30. So we would get 7.69, but if we round off this, it would be 7.7, and that would be our percentage. So we have our answer as 7.7%. So that is the answer, or the percentage error. So let's look at the next question here. Question 1 here. Question 1. What is the percentage error for mass measurement of 17.7 gram given the correct value as 21.2 gram? So we will take our formula. So solve. We will use our formula here. Percentage error is equal to value experimental, or experimental value, subtract accepted value, divided by accepted value then you multiply by 100. This will give you percentage error. So let's see what we have here. That is analyze. Given, what are we given here? What is the percentage error for a mass measurement of 17.7 gram? Given the correct value is this. So this is the experimental. Given experimental value is 17.7 gram, and the correct value is 21.2 gram. So let's put this into the formula. So the experimental is 17.7 gram, subtract accepted 21.2 gram, divide by accepted 21.2 gram, multiply by 100. So the gram and gram will be gone. We will remain with the numbers here. Okay, let's work them out using a calc. So we have 17.7 subtract 21.2, that is divided by 21.2, then multiplied by 100. So you would get negative 16. Negative 16. We have how many significant figures? 1, 2, 3 here. So our answer should be running at around there. So we will try to make it that way. 16.5. So we have 16.5%. So our percentage here would be 16.5. So let's try and go to another question. That is question B. Question B here asks, or question number 2, a volume is measured experimentally as 4.6 milliliter. What is the percentage error given that the correct error was this? So using the same formulae, we are going to solve for percentage error. So to solve for percentage error, you'll have value, or I mean experimental value, subtract accepted value, divide by accepted value, then multiplied by 100. So here we will have given, here is a value that is experimental, is given as 4.26 milliliter. Then we have accepted value. Here is given as 4.15 milliliter. So we put it into the formula. We will have 4.26 milliliter minus 4.15 milliliter divided by 4.15 milliliter multiplied by 100. So that is it. So let's do it here using our calc. So using our calculator here, we put it somewhere where it's clear. We have 4.26 subtract 4.15, subtract 4.15, divide, oh sorry, I multiplied instead of dividing. Okay, multiply by 100, then divide by 4.15. So we'd have 2.65. So we should put our answer into three significant figures. 2.65. This would be percentage. So this would be 2.56. And we said that depending on your result, you can tell if the percentage error is negative or positive, depending on if it is greater or smaller than the accepted value. So this one, because it is greater than the accepted value, it is positive. But if it was the opposite, then it would be negative. In the next video, we will be looking at error in measurement.